Hello students, you might be doing all those exercises and doing revisions as we have learned some of the basic theories of this chapter. Now we are moving towards another theory which is called as a magnetic field for the finite conductors. I have drawn two figures. It means that this is the only one theory, but I have represented two different methods for you. Whichever you like, whichever is convenient to you, just go through that. Let's say first of all we are understanding this figure, and it's another replica is over here, so you can choose anyone. First of all, I have, let's say, a length which is called as a L, and its a small segment is called as a DL segment through which our current is passing. And at this point, let's say I have mentioned that P, you can also mention that cross notation, which will give you that idea that amount of magnetic field is going to enter into that. Let's say in second figure also we have shown the same notations. Only the thing you can find it out is angles here. Because of that DL segment, current is passing through it, it is making an angle of a 5. Why my entire length part where my current I is passing, it is making an angle of a phi 1 on the right hand side, and another is called as a phi 2 and the left hand side. You can consider as this one point as an origin point O. So as far we are concerned, we are aware about that equation dB equals to mu 0 divided by 4 pi, and our ideal divided by r square sine theta. This is the primary equation. As you can say that this is my angle phi, and then my phi and this angle both are making an angle of that is called as a theta. So I'm doing some of the basic mathematical work for you. Theta plus phi is equals to, let's say, pi by 2, or you can say 90 degrees. So it's a vice versa application is also there, that is called as a theta is equals to pi by 2 minus 5. So you are aware that sine theta is equals to sine pi by 2 minus 5. So very first value we have received over here, sine theta is equals to call as a cos phi. So very first value, let's say I'm mentioning it as equation number A, and the main expression that is called as equation number 1. Next task from the figure, I can say that cos 5. So this is my angle 5. So you can just say that this one is 90 degrees. So this is the part which I am mentioning as a r. So I can just say that cos phi equals to a by r. So double implies r equals to a by cos phi. Let's say it will be the value of b, and apart with that, from the figure I am using that of tan phi because I am aware that I am supposed to use this value that is called as L by A. So it double implies L equals to A tan phi. So this is the equation number C. So I am mentioning that equation number A, equation number B, and equation number C, all these three equations has been placed in equation number, let's say, first one. So my equation first one will be looking like dB equals to mu 0 upon 4 pi as it is, and this is called as A, and it would be A sec square phi d phi. As you can say that that is called as ideal, A sec square phi d phi multiply by cos phi, and divide by that is called as a square divide by cos square phi. So I can just say that my dB that is called as mu 0 divided by 4 pi, and that would be giving me a by a cos, and cos that would be giving me cos 1 left, and that is called as a sec square theta. Pi by a is equals to cos 5 d phi. So now there is a limit I have to place because I have only one part is called as a dB. So I'm mentioning that my limits would be placed over here because of the d phi part. So on the another side I am putting that limits. Let's say on the left hand side I am putting that my limits starting from minus 5 to, let's say, plus 5 to then my values are integration of a dB integration of minus phi 1 2 plus phi 2, and mu 0 divided by 4 pi is outside, I by a cos phi, and that is called as d phi. So I have a mu 0 upon 4 pi I by a cos phi and d phi. So it is like the same values I have placed. The only change I have placed is that limits, and it is called as an integration of it. So I can have now value integration db is called as a b mu 0 divided by 4 pi outside, I by a over there, integration of minus phi 1 and plus phi 2 cos phi d phi. You are aware that integration of cos theta is equals to sin theta. So I may have value mu 0 I divided by 4 pi into a, and that is called as our value sine 5. Upper limit is of phi 2, lower limit is of phi 1. So I may have these values mu 0 I divided by 4 pi into a. Then first of all I have a sine phi 2 minus sine phi y, that is called as upper limit minus lower limit. So I may have the equation b is equals to mu 0 upon 4 pi. I can say that sine phi 1 plus let's say sine phi 2. So this is the equation which I have received. It means that whenever I have my current which is passing from this conductor, so it's a magnetic field received over here at this point P, which is giving me this equation of a magnetic field which is called as a mu 0 upon 4 pi and a sine phi 1 plus sine phi 2. For your better understanding, I am putting another equation, and this is an alternate method. So whichever you like the most, you can go through such type of method. So in front of you I am just starting another method. Let's say same type of arrangement you can see in a figure which is drawn beside you, where your angles are phi 1 and phi 2, but instead of that I have just mentioned that a theta over here. Yes, you can place or assume that theta is also over here, so there is no greater change in the figures. But I have just mentioned that instead of you can say phi 1 and phi 2, my values are over there. So first of all I'm mentioning this equation for you. B is equals to mu 0 upon 4 pi IDL divided by r square sine theta. Let's say this is my equation number 1. Now first of all I am putting that limits. So my value of a positive limit and negative limit, or maybe you can say that is my first limit and second limit. My first limit is called as a minus a cot phi 2, and next one is called as a cot phi 1. Let's say I'm mentioning there's equation number a. From this figure I can just place these values. So integration of db is equals to, let's say I'm bringing it out, mu 0 divided by 4 pi integration of IDL into a divided by a square plus L square raised to 3 by 2. You can say that this is L, this is a, and this is my value of R. You are aware that in a previous expressions we have just mentioned that mu 0 upon 4 pi R cube or R raised to 3 by 2. So directly I have placed these values of a cos theta, which is called as a by R, or cos phi a by R. So my equation which I have received over here, what I am doing is that integration dl. So integration dl, I want to just use this notation, L equals to a cot 5. I am doing that, it's a differentiation. dl, a is okay, minus cos x square 5 d phi. So my value of dl is equals to minus a cos x square 5 d phi. Let's say this is the value which I am mentioning as a c. This one is called as equation number, let's say b. Mentioning these values of a and c in the equation number b, I can get that integration db is equals to mu 0 divided by 4 pi, and its limits I'm just mentioning that the cot theta is equals to minus, and that is called as a plus. A is okay part for us, so minus phi 2 and plus phi 1. I can have minus a cos x square 5 d phi divide by I can have a square plus a square cot square 5 raised to 3 by 2. I have mentioned these values of L equals to a square cot square 5 in this expression, and the value of dl equals to minus a cos square 5 d phi, and the integration, that is limit of cot minus 5 and plus 5. So the part which I got over here after another simplification is that it would be minus mu 0 I into a square divided by 4 pi integration from minus phi 2 to plus phi 1. I can have cosec square phi d phi divided by a cube is outside 1 plus cot square 5, and its power is a 3 by 2. You are aware that I have just mentioned that a square is outside from this part and it is having power term. You are aware that a square multiplied by 3 by 2, so my power would be a raised to 3 is been left with me. So remaining part is called as a minus mu 0 I upon 4 pi a integration of minus phi 2 to plus phi 1, and then part left with me, that is called as a cosec square phi d phi 1 plus cot square is called as a cosec square cosec square, and it has been power has been left out, so that is called as a cosec square raised to 3 by 2. So my left part is called as a cosec phi, so my left remaining part is called as a sin phi d phi. I am just changing this limits, so it will be quite easy for me to just calculate, and you are aware that by changing the limits, its a sign is supposed to be changed. Integration from, let's say my limits are minus phi 2 and that is called as a plus phi 1, sine 5 is giving me minus cos 5. So just I'm just putting these limits over here, so these are the limits. Now next part is that I can have a mu 0 I by 4 pi a, then I can have my values cos phi 1 and cos phi 2. So you can compare that. In the previous expression we have derived that value of b is equals to mu 0 I upon 4 pi a, and that was a sin phi plus sin phi 2. Right now I have a cos phi 1 plus cos phi 2 only because we have that change those angles. So these are the very primitive change we can receive. Here my relationship between the b to a in the both these graphs are common, that is suggesting me that this is my b and this is that distance, so it's gradually decreasing. So this is called as it's a graph of a b versus a. Very first case of this one, in this expression, let's say I'm just following, you can also follow with your x component. Let's say my phi 1 and phi 2 both are perpendicular. It means that my at point p is making an angle of pi by 2, so I can get this value, that is called as a b is equals to mu 0 I divided by 4 pi a, and that is 2. So I can have mu 0 I divided by 2 pi a. So you can just directly remember this equation. Whenever I have these two angles, when my first angle is called as a pi by 2 and pi by 2, I can get this value, that is called as a mu 0 I and 2 pi a. Case number 1, when my angle 5 equals to 90 degree and my angle phi 2 equals to 0 degrees, I can get this value b is equals to mu 0 I divided by 4 pi a. And the third one, which is also important one, when my both the angles are phi 1 equals to phi 2 equals to 5, it means that you can see this figure, my both these angles phi 1 and phi 2 both are equal. So let's say this is an entire length L, but I can get phi 1 and phi 2 both are equal, call as a phi, so it would be coming over here, would be L by 2, and my equation would be look like this one. I can just place these values. Sine phi, first of all, L by 2 as per our figure, under a root of a square plus L square by 4. So I can get that sine phi is equals to L under root of 4a square plus L square. Putting in this expression, we can get that my magnetic field B, our phi 1 and phi 2 both are equal because both are 2 sine phi. So my B is equals to mu 0 divided by 4 pi, and that is called as a 2I by A into L under a root of 4a square plus L square. Friends, whenever you in exam they are asking such type of questions, without any hesitation, if you remember such type of angle values, first one, second one and third one, or you can draw this figure like this, phi 1 and phi 2, as per that would be, if this is pi by 2, so for cos that would be 0 degrees. Again you can have over this one 0 and this one would be, that is called as a 90 degrees, and this one both are equal, so you can get the same value. So in exams, without mugging up these values, you can use direct formulas, it would be quite helpful to you. So this is called as the our finite length conductor, and it's a magnetic field. So I have shown you both the methods, whichever will be convenient to you. You can go and follow its steps. And remember that in some of the school exams and board exams, this theory can be asked for the 3 or 4 marks. Thank you.